Hey guys, so we are going to do some factoring today. I have 3 examples for you. 36 is the first one. 36 is a constant, so we don't have to worry about any variables, just the number. So for this, I suggest a strategy of going in order. What I mean by that is starting with like 1, 2, 3, and then we'll continue that. Well, 1 times 36 gives me 36, so I know those are a pair of factors. 2 times 18 gives me 36. So those are another set of factors. 3 times 12 gives me 36. And then I'm going to keep going. I'm going to go from 3 to 4. Let's just say I don't know 4 times what? I don't know what that number is that will give me 36. A strategy I can use is division. So instead of trying to find what I'm going to multiply by, what I can do is divide 36 by 4. And I can put that in my calculator. When I do, I'm going to get 9. All right, so then that means that 9 is the factor that goes with 4. Okay, I'm going to keep going. 5 times, again, I don't know what 5 times what gives me 36, so I'm going to use division to help me. When I put this in the calculator, I end up getting 7.2. All right, so a tip is if you get an answer with a decimal, when you try this division strategy, that means that 5 is not a factor, okay? We don't want decimals in our answers. So I'm going to get rid of the 5, and I'm just going to jump to my next number, which is 6. I know that 6 times 6 gives me 36. I know that 7 is not a factor. It's going to give me a decimal. The other number that I would have to multiply it by would be a decimal, so that's not a factor. I know that 8 is not a factor. 36 divided by 8, I don't even know what that is, but it's going to give me a decimal number, not a factor. And then we're back up to 9, which we already accounted for. So that's how we know that we're done. And so we can say now that these numbers, 1, 2, 3, 4, 6, 9, 12, 18, and 36 are all factors of 36. All right. So that was a constant. Now we're going to do a binomial. All right. I think the best strategy for doing any expression that has multiple terms is to try to expand those terms. What I mean by that is we're going to look at 2x by itself. I know that the only factors of 2 are 1 and 2. 1 doesn't really help us here, so I'm just going to say the only factors of 2x are 2 times x, right? That's how I get to 2x. There's really no other combination. Now, negative 6 is a little trickier because we have that negative. So I could have a positive 1 times negative 6. I could have a negative 1 times positive 6. I could also have positive 2 times negative 3 or negative 2 times a positive 3. All right, so there's 4 sets of factors for negative 6. Here's the thing. Now I want to look for, any factors that these 2 terms have in common, and we're lucky because they do have 1 in common. They have 2 in common. So I'm going to rewrite this over here. So if we start with 2x minus 6, I'm going to expand that into 2 times x. And then we have the 2 times the negative 3. All right, because that was the set of factors over here, and this was the set of factors over here that had that greatest common factor. What I'm going to do last is I'm going to pull out the greatest common factor. All right, and I'm actually going to put that outside of the parentheses. Okay, so I've accounted for the 2, I've accounted for this 2. What I have left that's going to go in the parentheses is x from here, and then the negative 3 from over here. All right, so this would be my answer in factored form. What's really good is, I can check my work. Okay, so if I'm not sure if I did it right, what I can do is go ahead and use the distributive property and distribute this 2 back into the parentheses. 2 times x is going to give me 2x. 2 times negative 3 is going to give me a negative 6, which, bam, is what we started with. So that's how I know I'm correct. Okay. This is the final and hardest example, but we're going to take a lot of the strategies that we used in that last example and use them here as well. Namely, we're going to start by expanding these two terms into their factors. Again, the good thing about 7, just like 2, is it's a prime number, so the only factors are 1 and 7. 1 doesn't really help me, so I'm just going to leave it out. So I could say this is, 7 times y squared. I also can break that up even more. So I know that y squared is the same thing as y times y. So I can also break it up into this. Now this is now in the simplest form, or the most expanded form, should I say. All right, so we're going to do the same thing with 14y. I could say it's just 14 times y. I could also, the thing is, I can also break up 14. So I know that the factors of 14 are 1 times 14 and 7 times 2. Well, I want to use the 7 times 2 because I also have a 7 over here. So I'm going to go ahead and break up that 14 into 7 times 2 and then bring down that times y. Okay, and I can't forget that I have a plus here, so I'm going to bring that down as well. All right, so now we're working with this part right here, okay? And just like in the last example, I'm going to go through and I'm going to see what factors I have in common. Well, I know I have a 7 and a 7 here, and I also have a y and a y. So I'm going to pull both of those out, and I'm going to multiply them together. So it's really 7 times y, 7 times y. So what I'm going to pull out is 7y. All right, and then whatever I have left, I have a y that I did not pull out, I have a plus that I did not pull out, and I have a 2 that I did not pull out, okay? And now this is the factored form of what we started with. Again, if I want to check my work, I can do that and by distributing the 7y back into the parentheses. Before I do that, I'm going to assume, or I can assume, that the coefficient of y is 1. So I'm going to go ahead and multiply 7 times 1 to get 7. Then I'm going to multiply my base of y. I'm going to keep my base, and I'm going to add my exponents because that's an old exponent rule we learned a long time ago. So I keep my base y. 1 plus 1 gives me 2. And then I'm going to do the 7y times the positive 2. Well, 7 times 2 is a positive 14, and then I keep my y. And bam, that is what we started with, so we know that we did it correctly.